critical points. So, a lot of you in your high school mathematics career have probably at some point, even back in like Algebra 1, you were probably asked to find on the graph of like a parabola, for example, if it's concave up, find the min, concave down, and find the maximum. Well, that's exactly what finding critical points is going to allow us to do, except we're looking at it from the point of view of now bringing derivatives into the conversation. So now we're going to say that critical points are where you have f prime of x of some f of x equals 0, or it does not exist, which you're going to commonly see in textbooks. Does not exist abbreviated as DNE. So what might an example be of where this would not exist? Well, if we're trying to find the derivative at some point, for example, well, in order to do that, we would need to have the exact same slope of that point approaching from the right and the left. And it might not be obvious at first why that might not be the case all the time. But for example, there might be graphs where you have some kind of discontinuities, like a point discontinuity, for example, where you're going to have just like some point in your f of x where you can't actually have it as defined at that point. So in other words, you can't actually get an answer by taking the derivative at that point. You might have an asymptote or something like that going on at that point, but I can do a different video about the different types of discontinuities that you might run into. So an example of where it might be does not exist would be, for example, this might be your f of x has absolute value of x, in which case if you're trying to find the f prime of 0, like a derivative where x equals 0 here, you'll find that from one side we have a slope approaching at a positive 1, but a negative 1 slope from this side, or in other words, it's not the same slope coming from both directions, so therefore it does not exist. Okay, so what if we had a graph like this, for example, where this might be some kind of a cubic, because notice how here you're going to have 3 different roots, at least 3 different roots as far as we know, but if you're going to try and find where the critical points are, then probably it's going to be here and here, because this would be your max, this is your min. And if you're going to try and draw different tangent lines here, then you would be able to construct what this graph would look like if you did that an infinite amount of times. Being able to find different pieces of information about graphs is a very important skill, and calculus gives us the tools to be able to do this. So if we're thinking about the tangent lines here, well, each tangent line is in the form of y equals mx plus b, if you recall, because it's a line. Okay, so and each tangent line here is going to be intersecting the graph, but also going through some particular point that we care about, okay? So if we do point slope form, with y minus y1 equals m times x minus x1, then this is the way that we can figure out an equation for the tangent line if we know what the slope is and some point. How can we figure out what the slope is at some point? Well, actually, m equals the slope equals the rate of change, but actually rate of change instantaneously at some point, that's actually exactly what a derivative is. So we can also say that m equals f prime of some x at some point. So this would become, if we want to find any tangent line for any like continuous kind of polynomial like this, then our tangent line would be given for some point x1 comma y1 as y minus y1 equals f prime of x times x minus x1. But notice that at the max and min, the graph flattens out with how it's changing at that point. Hence, we're going to have zero change at precisely the max and min points. So basically, when we're trying to find the max and min, which critical points is going to give us the tool to do, then at max and min, f prime of x equals 0. So, okay, basically you would take your f of x, you would do what you'd have to do to get the derivative of it, and you would set that equal to 0 and figure out what x you would have that would give you that. So, and by the way, this is going to be useful for problems you're going to be asked to do on your tests and homework that have to do with optimization. So that's going to be something you're going to hear a lot, and optimization being you're trying to find the highest or the lowest point on the graph that you're being asked to figure out. So we're going to revisit this, but I thought this would be important to go over in the video. So now you have the skill, and hopefully you found this helpful. So come back for the next one where Joe shows you how.